Hello students, today we are going to solve some numerical problems. These numerical problems are related to chapter 1 of the Conscience Physics book class 10 ICC. So these numerical problems have been taken from the Conscience Physics. So today we will be solving the problems, and in the process we will be discussing the theories related to it. Okay, so coming to question number 1, what it has been said, let us first consider. A diagram has been given. It shows that there are two forces, F1 and F2. One is having 5 Newton value and another is having 3 Newton value. These two forces are present on the horizontal bar, which is balanced at a point O. Now the first force is applied at a point A from the point O, which is 2 meter, that is the length of the OA is 2 meter, and the force F2 is applied at point B, which is at a distance of 4 meter from the pivoted point O. So this is the given information. Now the question has been asked, first part, you have to calculate the moment of force F1 about the point O. So this is the first question. So how can we calculate the moment of force? I think you all know what is the formula of the moment of force, isn't it? You know that moment of force is equal to the force applied into the perpendicular distance of the point of application of force from the pivoted point. Fine. So let us begin. Now see, how can we calculate the moment of force? So for this, just let us go to the another page and we will be solving the problem here. Okay, so coming to solution number 1. Solution 1. So let us see how can we solve this problem. See, the figure has been given like this, something like this. There is a straight horizontal bar. Okay, and a force, it has been pivoted at a certain point like this. Okay, and from this, here a force F1 is applied. The value of F1 is, if I'm not wrong, just let us check it once, it's 5 Newton. Okay, F1 is having a force of 5 Newton and F2 is having a force of 3 Newton. Okay, so F1 5 Newton, this is point A, this is point O, and this is point B. Okay, so at point B, a smaller force of 3 Newton has been applied. F2 equals to 3 Newton. Okay, so how can you calculate the moment of force due to the moment of force due to the force F1 about the point O? So coming to the first part of the solution. So coming to the first part of the solution. Okay, so first part, so moment due to F1 about point O. Okay, about point O, about point O. Okay, about point O. So what is the moment? Let's just consider it, say M1. Okay, so M1 will be equal to the force applied. How much is the force applied? So force applied is F1. So F1, the formula is something like this: F1 into the perpendicular distance means OA. Okay, so this is equal to 5 Newton into the OA distance has been given to be as, how much the OA distance given? Let us see the question once. Is 2 meter and the other side is 4 meter. So this is 2 meter length. This is 2 meter length. Okay, and this is 4 meter length. Fine. Okay, so what will be the moment of force? 5 into perpendicular distance is 2, hence it is 10 Newton meter. Now this 10 Newton force, 10 Newton meter moment causes the horizontal bar to rotate in the anti-clockwise direction. Hence this moment can be referred to as the anti-clockwise moment. So what will be the formula of anti-clockwise moment? It will be what will be the notations? A C W, anti-clockwise. Okay, A C W denotes anti-clockwise. Okay, next coming to the subpart 2, what is the moment due to the force F2? Let us see. Moment So I think seeing the solution of the first part, you can easily do the second part also. Moment due to f2 about point O. Okay, so let us consider it as to be m2. It will be equal to f2 into perpendicular distance here is OB. So f2 force is about say 3 Newton into perpendicular distance 4, so it will be coming to be 12 Newton meter. Now this force f2 causes the bar to rotate it in the clockwise direction, isn't it? So this will be clockwise moment. I am writing it as in short CW, clockwise. Okay, and the third part of the problem says the net moment due to these two forces combined or taken together. Then obviously the net moment will be the difference of these two moments, as because these two moments, why you are taking difference, these two moments are causing opposite direction rotation, isn't it? The f1 force is causing rotation in the anti-clockwise direction, whereas the f2 force is causing the rotation in the clockwise direction. Hence the net moment, I can write it as net moment equals to, generally clockwise moment is taken to be as negative and anti-clockwise moment is taken to be as positive. Okay, so here what will happen if you do not consider the sign, just write the direction at the end. We can also do it in that way also. So here the net moment will be 12 minus 10, that is equals to 2 Newton meter, and its direction will be clockwise. So the net moment, so what will be the effect of these two forces? Ultimately the horizontal bar AB would be rotating in the clockwise direction about the point O with a moment 2 Newton meter. Okay, so this is the solution. Okay, I think the concepts are clear to all of you. Okay, now let us go on, quickly move on to the question number 2. So what does the question number 2 says? Let us see. So question number 2 says a uniform meter rule balances horizontally on a knife edge placed at 58 centimeter mark when a weight of 20 gf is suspended from one end. Fine. So let us draw a uniform meter rule. Let us consider the solution. What will be the solution like? So it's solution number 2. First of all, let us draw a uniform meter rule. So uniform meter rule, something is like this. Uniform meter rule means it's a scale, as you say it in common words, having a length of 1 meter. So uniform meter rule. So uniform meter rule in this case, uniform meter rule. Okay, so this point is the 0 centimeter mark. This point is the 100 centimeter mark. 100 centimeter mark. Okay, and now let us see where it has been balanced. The question says that it has been balanced on a knife edge placed at 58 centimeter mark. Okay, 58 centimeter mark. So if I consider the midpoint to be something point like this, then 58 centimeter slightly tilted towards the right. So this is my 58 centimeter mark. I think the concept is clear. 58 centimeter mark will be something like this. So we draw a knife edge like this. Okay, so this is the 58 centimeter mark. Remember, 58 centimeter, it has been given in the question, 58 centimeter mark. Okay, so now it has been said that a weight of 20 J is suspended from one end, and under that condition the meter rule is in balanced or equilibrium condition, that is it is not rotating on any side. Then the first question has been said, draw the arrangement. So if I need to draw the arrangement, I need to know where the, on which side the 20 G weight will be suspended. That is a big question. Now see, you know that for any object the weight of that object always acts to its midpoint, especially in case of a straight bar or straight rod like this. Okay, so if I consider that the weight of the rule is say WGF. Okay, so just note it down, weight of the rule is WGF. Okay, so let us consider, let weight of rule be WGF. Okay, so if I consider the weight of the rule, that must be acting to the midpoint, that is the 50 centimeter mark, isn't it? So if I consider the 50 centimeter mark, it will be somewhere at this point. I think it's okay. So this is 50 centimeter mark, so I'm just writing it in a very small. Okay, so that it is easy to understand. Okay, 50 centimeter. Now the weight of the rule is acting basically at this point. So weight of the rule is acting like this. Okay, just consider some another color, it will be easier to understand. The weight of the rule is something like this, acting like this, isn't it? Okay, so it is WGF. WGF. Okay, WGF. WGF. Okay. Now, so from this figure, can you say that at this moment the scale would be, meter rule would be rotating in the anti-clockwise direction, isn't it? This WGF tries to rotate the scale in the anti-clockwise direction, isn't it? Fine. So how can you rotate the rule, balance the rule? So definitely I think it is clear that the 20 GF must be suspended on the right hand side, isn't it? Right hand, because if we suspend the 20 GF weight on the left hand, then definitely it will cause the rule to move on the anti-clockwise, sorry, clockwise direction. So I need to balance it. The weight is already causing the scale to, meter rule to rotate in the clockwise, anti-clockwise direction. So in order to balance it, I have to put the weight 20 GF on this side. So I think the concept is clear, how you can determine on which side the 20 GF weight must be suspended. Okay, fine. Now it has been, next question, second part has been asked. So first part we have already completed. We have done the diagram, we have shown the arrangement to the diagram. Now let us consider the weight of the, now we have to find out, determine the weight of the rule. So this is the first part. Second part is the weight of the rule. For this, what happens, we know that under equilibrium condition, total clockwise moment is equal to total anti-clockwise moment, isn't it? So what is total clockwise moment? Let us see the total clockwise moment will be due to the 20 GF. So clockwise moment, CW moment, due to due to 20 GF. Let us consider this to be as M1. It will be equal to the force 20 GF into perpendicular distance. Now what is this distance? What is this distance? Let us see. If I say what is this distance, this distance will be, I think, 100 minus 58, isn't it? 100 minus 58, so it's 42 centimeter. This distance is 42 centimeter, isn't it? So it will be, the moment of force will be 20 into 42 GF centimeter. Just keep it like this, no need to calculate at this moment. Okay. Now the, what will be the anti-clockwise moment? Anti-clockwise moment will be created due to the weight of the rule. Anti-clockwise moment, anti-clockwise moment due to WGF. Okay, you can write it like this. So let us consider it is M2. So M2 will be, we don't know the weight W, so W into, so what will be the small distance? What will be the small distance? This is very small tiny distance. What will be the distance? This distance will be 58 minus 50, isn't it? So it's 8 centimeter. So we can write this as W into 8 centimeter. You can, isn't it? W into 8 GF centimeter. Okay. Now under equilibrium condition, what you can say? So under equilibrium condition, you can write it as like this. Under equilibrium, by the principle of moments, principle of moments, total anti-clockwise moment is equal to total clockwise moment. So total anti-clockwise moment, ACW moment, is equal to total clockwise moment, isn't it? Total clockwise moment. So hence you can write that the M1 equals to M2. So you can write M1 equals to M2 from this statement. Okay, or from this you can write 20 into 42 20 into 42 will be equal to W into 8, or from this you can write, or W equals to 20 into 42 by 8. Okay, so 4 2 is 8, 4 5 is 20, 2 21, so the result comes out to be 105. Okay, hence you can write, that the, like just writing the answer here, therefore weight of meter rule, just writing it as rule, is equal to 105 gf. Okay, so this is the solution. So I think the solution is clear to all of you. So okay, so till then we'll be discussing more problems in the next classes. For today's video, today's lecture, we'll stop here. Thank you, goodbye.